shrink. That is pretty much defining the footprint of the box now. So from an engineering perspective, that's probably been our biggest challenge. There are other subsystems in there that we've put a lot of time and effort into making them better, but that's the biggest one from a size perspective.
You know, NASA, as an agency, we develop a lot of cool technology that we use in space, but then a lot of that technology can be used back here on Earth. How could NDL be possibly used in terrestrial applications?
Oh, that's an excellent question. There are a lot of different ways that it has usage right back here. One of them is for autonomous cars. You know, you see that as a up-and-coming, emerging technology. A small version of NDL can be used to track the speed of vehicles very precisely. In theory, you can also track objects around the vehicle also, so you can use it to some degree for hazard avoidance for the vehicle there too. But giving it a very precise vehicle speed is of utmost importance to any autonomous vehicle. It needs to know precisely how fast it's going.
Let's kind of fast forward to next year. Where are you going to be when your NDL system is the descent stage of those two landers, and they're going to about to land on the lunar surface, and NDL starts working, and it's working beautifully?
The state we'll be in is a state of happiness. That's the state we'll be in. We will be extremely excited, extremely elated that this has worked successfully.
Well, Glenn, thank you so much for taking the time out today to kind of give us the brief history of NDL and the technology. I'm hoping, you know, I know you're gonna do a spot landing on the moon.
Yep.
And I know you're gonna do one on Mars one day.
Yep.
But what I want to see is I want to be able to drive in a car autonomously without driving, knowing that Glenn and Farzine and the team have an instrument on board that's getting me from A to B.
Yeah, excellent. I hope to see that day soon. All right.
Thank you, sir.
Thank you so much, Chris.
Thank you.
I'm very excited about the NDL technology for sure, but this autonomous driving stuff is awesome. And if these guys don't deliver, I'm going to call them personally, see if they'll set up a carpool with me, because I'm ready to avoid the traffic situation, get some productivity on the road.
Hey, you know, one of the bigger challenges that they're dealing with is getting it down from that suitcase-sized box to even smaller to work inside of vehicles. The technology has already been transferred, and they're working on it actually close to here at Langley where we work.
Well, don't forget, Walt said at the beginning of the show, he talked about splice, because remember, NDL is part of a bigger suite of instruments. So you imagine not only having NDL, but then you have the terrain relative navigation built in, and then you have the hazard avoidance and detection. One day you're going to be driving, and you get some type of obstacle in front of you, it's just going to drive around it, and you don't have to worry about touching the steering wheel.
Perfect.
Let it go on its own.
And you know, it's interesting because that size reduction, they're talking about getting the basic box down to the size of a can of soda. So just think of, there's the lander for Artemis and things like that, but how many other landers that are going to be involved in space exploration that can use that same technology?
Now, we do have some of that same technology in our cars today. We have the side view, the lights that let you know that people are next to you.
Sure.
But that's using cameras. But this is more precise, this is better technology, and hopefully that will be incorporated in other things besides cars and jets and things
Absolutely,
like that.
Absolutely. Now, Chris, what do you think about the long-term prospects? We've seen a technology like this, and it's being developed and deployed. What's the future look like using this technology down the road?
I can't wait till we have those 2 CLIPS missions where the NDL will be flying on the landers. Hopefully we'll get successful data, and eventually if we send humans in 2024, they'll be on the human landers, and then eventually as we get on to Mars, this will be a staple for all the technology and all the landers that will be sent out.
So right now we're doing a show on technology that'll be part of that first return to the moon that we'll have in 2024, and then eventually landing on Mars.
Where are you guys going to be in 2024?
You know what? I'll probably be at the Kennedy Space Center. Doing some programming, doing some live shows with you and you probably. And
hopefully.
Hopefully, yeah.
That's right.
Yeah, and I think we're just going to get those goosebumps that we had for the many milestones that we've witnessed over the years here at NASA. You know, I was alive when man stepped on the moon, but I was very, very young. So I didn't remember it like I remember the shuttle mission. So this is going to be very interesting, and I'm looking forward to it.
You know the difference is going to be?
What's that?
For 2024, he'll have his AARP card.
You know what? That is absolutely right.
But you know, look, it won't matter. What's really interesting is all this technology that we see in development now is going to be riding on the lander, on part of Artemis.
That's right.
taking the first major step in this process, and we're all going to get to witness it. That is one of the most exciting things that I can think of in terms of NASA in a long, long time, and I'm excited about it, so I really don't care where I'll be.
And knowing this technology right here is a part of Artemis. So,
Partimus. Partimus of Artemis.
Artemis of Artemis.
You're watching NASA Edge.
An inside and outside look
At all things NASA.
Targeting the next U.S. launch of astronauts, another successful space station resupply mission, and honoring pilots for National Aviation Day. A few of the stories to tell you about this week at NASA. NASA's SpaceX Crew 1 mission to the International Space Station is targeted for launch no earlier than October 23rd. NASA certification of SpaceX's crew transportation system will allow for regular crewed flights to the station, ending our sole reliance on Russia for access. On August 18th, the Japan Aerospace Exploration Agency's HTV-9 cargo spacecraft left the International Space Station after a 3-month stay. HTV-9 delivered about 4 tons of supplies and experiments, including new lithium-ion batteries used to upgrade power systems. We celebrated National Aviation Day on August 19th with special recognition of the skills, abilities, and crucial role of pilots and aviators. The annual observance falls on the birthday of the world's very first pilot of an airplane, Orville Wright. Find out more about our groundbreaking aeronautics research at nasa.gov/flight. The one-of-a-kind engine for NASA's X-59 quiet supersonic technology airplane was delivered to our Armstrong Flight Research Center in California, where it will be checked out, then sent to nearby Palmdale, California, where the plane is being built. The engine will power the X-59 on missions to gather public reaction to the quieter sonic booms the aircraft is designed to produce. Technicians at our Kennedy Space Center in Florida have been busy installing the spacecraft adapter cone that will connect the Orion spacecraft to the Space Launch System rocket for the Artemis 1 mission around the Moon. This is one of the final major hardware operations for Orion prior to integration with the rocket. We're celebrating 15 years of our Mars Reconnaissance Orbiter, which has helped reshape our understanding of the red planet and provided a slew of stunning images along the way. As of early August, just one of the spacecraft's 3 cameras alone had taken more than 6.8 million images and generated 194 terabytes of data sent from Mars since 2006. That's what's up this week at NASA. For more on these and other stories, follow us on the web at nasa.gov/twan.
So, you're planning your next vacation to the cosmos. You've picked out a few potential places to go, you've marked your map, and you've also somehow rigged up your spaceship to travel at almost the speed of light? How are you going to, Well, here we go, I guess. Before you fly off all willy-nilly, however, there are some important things you should probably know about approaching the speed of light. First, a lot of weird things can happen, like time and space getting all bent out of shape. For example, if you're moving at nearly the speed of light, according to the clock inside your rocket, you'll only take a bit more than half the time to reach your destination compared to what a clock on your planet would say. The end result is that while your clock might move normally to you, you'd see the clocks back home and move further when you return, so you might want to reschedule your dentist appointments before you leave. Also, because you're going so fast, what would otherwise be just a few hydrogen atoms that you'd run into quickly becomes a lot of dangerous particles. So you should probably have shields that keep them from frying your ship and also likely you. And finally, you wouldn't want to accelerate too quickly toward the speed of light, because, well... However, since it looks like you've figured all that out already, let's talk about how long it takes to travel around the universe. While you will be traveling very fast, the universe is also a very big place, so you might be in for some surprises. For example, even though you're traveling at almost the speed of light, and, as you remember, the time and space weirdness will make the distance seem shorter to you, your rocket's clock will still say it takes a bit more than 9 months just to get from the Earth to the edge of the solar system. According to a clock on Earth, it's even longer, over a year and a half. That's not too bad, but to get to the next star system, your clock would say it took you just over 2 years. Okay then, If you want to get to farther out vacation spots, however, you'll probably need more than a few extra snacks. A trip to the Andromeda Galaxy, our nearest large neighbor galaxy, could take over 1,000,000 years, and a trip to the farthest known galaxy where it currently is might take over 15 billion years, which is more vacation time than I think I'll ever have. Of course, again, since time gets all weird the closer you get to light speed, your actual travel time will be a bit shorter than that, depending on just a couple of... That's something we can talk about later. Either way, that should sum up some of the big things you might run into with near light speed travel. But in the meantime, make sure to buckle up, enjoy your snacks, and please, be safe out there.
If they're going to make something that we don't know how to burn in a rocket engine, let's do some research. My name is Diane Linney, and I am working to build refineries and gas stations on the Moon and Mars. One of the first things we need to do is we need to dig up our dirt. I was working my vegetable garden using a small rototiller. The dirt was very dry on top, but of course as soon as I tilled it up, I got some wet dirt. And I thought, wow, we're trying to harvest the water out of the soil on the Moon and Mars to process it into something more useful. We get to play in our sandbox. We can measure how much soil went up into the scoop. Actually, I wanted to be a lawyer when I was in high school. My high school physics and calculus teacher said, you're a woman and you're really good in math and science, you should try engineering. Up until now, we've taken everything we need with us. We're trying to build gas stations and refineries so we don't have to bring all our propellant with us. Our ancestors called it living off the land. It's just a lot of fun that we get to try and push the technology and make new things.
The complexity, the systems that we've brought together in this one place to do something that very few places in the world do. Launch humans to a low Earth orbit, and hopefully with a new program into farther reaches of space. So when you go to a system or a place like that, you can't help but be overwhelmed.
Every space shuttle mission began with a fiery liftoff from Launch Complex 39 at NASA's Kennedy Space Center. The launch complex for the space shuttle had two pads, Pad A and Pad B. If the launch pads demonstrated anything, it's that complex is the right word for the two pad areas that handled the shuttles for about a month before they made their trips into space. Outfitted with everything a spacecraft and its crew would need to take the final leap into space, the pads handle fueling duties and crew support and held precision machinery for a range of payloads. Its graded floors and gray paint, along with armored boxes for instruments, telephones, and elevators, revealed a style more Spartan than space age.
You always find something that you didn't know. You've got a lot of steel, a lot of wires and lights and tubing and that kind of stuff. It interfaces to a flight vehicle, so you have those complex interfaces, and there's always something to learn. It may look kind of Spartan, but yeah, it's got its hidden treasures.
The launch pad and all its fittings were built to withstand the brute force of a launch, which would rattle the pad with intense fire, corrosive exhaust, and thunderous sound waves.
Tested, let's put it that way. There's a tremendous amount of force that gets placed, in liftoff on the structure, on the mobile launch platform, the MLP, heat, acoustics.
Each pad featured a shallow slope concrete pyramid about 40 feet high with a flame trench carved through the middle to channel exhaust away during launch. Launch pads were first built for the Saturn V rockets of the Apollo program. Back then, the launch complex did not have any permanent service towers because the support structure was on a mobile launch platform and traveled with the rocket to the pad.
There's an element of the history, to think back and to stand in places where people were launched to the moon. that has a real place for me.
For a shuttle, a pair of support structures called a fixed service structure, or FSS, and a rotating service structure, or RSS, were built at the pad and would remain there for all 30 years of flights. Both structures carried wiring and other infrastructure needed to support and protect a space shuttle for weeks at a time. A shuttle stack, meaning an orbiter attached to an external fuel tank and a pair of solid rocket boosters, would move to the launch pad about a month before liftoff. The shuttle was connected to networks of data cables, water lines, and the fueling system.
Unless you were out there when the workers and technicians and engineers were out there, it's hard to capture the elements of these people working together as a team, doing complex tasks, complex jobs, with a vehicle there that's just loaded with solid propellant. It could be dangerous as heck, it really is, and they did it routinely and made it safe.
There's also a bathroom, complete with stainless steel fixtures instead of brittle porcelain.
When we do give give some tours up there, or groups come up there, I always point out that that's the last toilet on Earth.
Before launch day, the RSS covered most of the shuttle and provided a clean room that safely moved space probes, space station modules, and even NASA's Hubble Space Telescope into the shuttle's cargo bay without contaminating them. Other parts of the launch pad gave workers access to most areas of the shuttle stack, which stood up to 184 feet above the surface of the mobile launcher platform. The launch pad was woven throughout with propellant lines, wiring, and machinery.
There's so many complex things out there that could literally kill you, if you did something wrong, or not just yourself, it could be, devastating. And we do it safely, routinely, day in and day out. That's testament to the workforce and to what this nation built from the Apollo era, learning through hard lessons.
Launch day was also when most of the structures at the pad came to life, mostly by remote control to keep people a safe distance away. The huge white spheres on either side of the shuttle will pump supercold liquid hydrogen and liquid oxygen into the shuttle's external tank. Each propellant had to flow through long lines from the spheres about a half-mile from the shuttle.
As you get closer to launch, things just kind of step up, and you can feel it. Just pure excitement, really, as you're getting closer.
The last people at the pad on launch day were the astronauts. They headed into the White Room, a kind of cramped locker room, before boarding the shuttle. With 2.5 minutes to go, the gaseous oxygen vent arm and its white beanie cap retracted from the top of the external tank, clearing the way for the launch. About 16 seconds before launch, some 300,000 gallons of water poured onto the launch pad. Though what might seem to be done to protect against the blazing fire, the water was actually for sound suppression to dampen the vibrations produced by 7 million pounds of thrust. The fire and thunder would produce a show unlike any other.
Go for main engine start. We have main engine start. 2, 1. Booster ignition and the final liftoff of Discovery. A tribute to the dedication, hard work, and pride of America's space shuttle team. The shuttle has cleared the tower.
Some of our team would work late shifts, so you kind of had to go home and sometimes, watch it from the river, just like the other folks would, or something like that, which I actually kind of enjoy. If I couldn't make it into center in time, just kind of being out there with the general public and everything like that. Just sit back and watch the kids and people enjoy a beautiful launch. It's part of my joy, I guess.
Now that the space shuttle is retired, the pads are being prepared